Welcome to Introduction of Machine Learning. You have seen machine learning in your everyday life so many times, but maybe you weren't aware that it is machine learning allowing these things to happen. Every time you receive a spam email, there's an engine that learned from previous emails and was able to classify this email as a spam. This type of machine learning is called classification. Whenever you are on Amazon shopping and you see a list of recommendations just for you, there's a recommendation engine that learns from what items you've looked at and what you've bought before and what similar people have bought, and is able to generate your recommendation list. When you send a mail in the post, you don't expect the person to look at the address and find the city you are mailing. The whole process is automated using machine learning. Machine learning can be looked at as when a program comes up with its own rules to solve a problem. We don't expect a computer to learn a task perfectly. If perfection were possible, we generally wouldn't have to use machine learning. There are two main kinds of machine learning: supervised and unsupervised learning. In supervised machine learning, we would give the algorithm known data to get trained. It learns from these data and become able to predict the result of similar inputs. Let's say we want an algorithm that takes a DNA sequence as an input and returns the category of this sequence. We train the system with a set of DNA sequences and their associated experimentally determined categories. When the system is trained, we can pass an input to the algorithm and expect an output close to the known result as possible. Unsupervised machine learning is when the learning model is not given any training data set. One example of that is clustering algorithms. It is widely used in grouping genes into similar expression profiles. Another widely used example is dimensional reduction. If you have some medical data of patients and you wish to categorize them into few groups, not all the test measurements on the patients will have an effect on which group this patient belongs to. However, it is not easy for a human to know which is which. Machine learning algorithms do not care usually about what the data represent or what application it came from, as long as you can represent the data numerically. Many times, you won't be able to understand what exactly is going on in a trained system. If it works, then that should be enough. Finally, machine learning methods are able to do nonlinear decisions. The relationship between the data will not be straightforward.